We are talking about the 8 structural components in an abstract of a life science paper. I have been emphasizing that those components proceed linearly down a straight line, starting from the first background component and ending with the last implications component. But today, I would like to introduce another viewpoint for you. I can visualize 2 circular loops or loop structures in a well-written abstract, in addition to a straight line structure that connects the structural components sequentially. A loop is opened by one structural component and it is closed by another structural component. It is a beautiful structure, and it is different from a circular logic, which is a bad structure. Can you identify 2 good loops in the abstract written by the Nobel Laureates? Let's focus on one of the loops today. This loop is about the results. We will focus on another loop in the next episode. Hi everyone, welcome to the Foundational Skills in Life Sciences podcast. I'm your host, Dr. Synaptologica. We discuss the skills that life science scholars learn, use, and improve throughout professional activities. Your benefit is expressed in my motto, learn the skills, enjoy academic life. Last episodes. We have been analyzing the abstract of the Milestone Article 1 of the 2023 Nobel Prize Laureates in Physiology or Medicine. It was written by the laureates, Dr. Katalin Karikó and Dr. Drew Weissman, and it was published in 2005 in the journal Immunity. I will show you a link to the paper in the episode description. 2 episodes ago, in episode 46, we started a step for reading the abstract. The step was, step 14, analyze the abstract structure of the article. It had the following 3 substeps. Step 14-1, review 8 structural components of abstracts. Step 14-2, give a sequential number to each sentence of the abstract. And step 14-3, analyze each sentence of the abstract. We have been working with this substep, and we will keep working this substep today and in the next episode. In the last episode, episode 47, we analyzed the first 3 sentences of the abstract. The first sentence, or sentence 1, was for the background component. The second sentence, or sentence 2, was for the known component. And the third sentence, or sentence 3, was for the unknown component. We then focused deeply on sentence 2, the known component. We talked about a very general principle. When the known component is present in an abstract, it is usually a good sign. It is likely that the rest of the paper is written logically and well. When the known component is absent, it could be a bad sign. The rest of the paper could be poorly written, although it can be well written. It is not a strict rule, but this general principle of mine has been helpful whenever I read papers myself and whenever I peer review manuscripts submitted to journals. The beauty of sentence 2 in our abstract of Milestone Article 1 was that it logically extended sentence 1 to sentence 3 so that it served as a logical bridge. Another beauty of sentence 2 was that it shows us a glimpse of how the authors obtained the initial idea of the work. It could be different from reality, but still it was helpful for readers outside the field like me. I emphasized that one sentence was followed by another sentence, and it was followed by still another sentence in small steps without any big jump between the contents. This way, the sentences proceeded logically along a straight line. And because of the stepwise progression, the structural components were presented logically. We could understand the contents easily. This is what I would like to call the linear and sequential progression of sentences or structural components. today's episode. Today, we will continue following the linear and sequential progression, and we will examine the other sentences of the abstract. But on top of that, I would like to introduce nonlinear progression as well. I can visualize two loops within this abstract. A loop is opened by one of the structural components, and the loop is closed by another component that lies far from the loop opening component. There are multiple sentences between the loop opening and the loop closing components. So a loop does not show a sequential progression along a straight line. It is nonlinear. Please let me add a short note. In mathematics and engineering, the words linear and nonlinear will mean different features from my words here. In my episodes about reading life science papers, linear or nonlinear progressions simply mean that the progression is along a straight line or not. I wanted to say these simple definitions for my episodes because I love mathematics too. Let's get back to the main talk. In today's episode, we will talk about the first of the two loops, together with linear progression of the components. We will talk about the second of the two loops in the next episode. If you can start visualizing those loops, you will be truly glad to appreciate the beauty of this abstract. After you listen to this episode and the next, I'm sure I can hear you say, "What a beautiful and well thought out abstract this is." Linear and sequential progression. The first three sentences of the abstract showed linear and sequential progression of the structural components. The remaining sentences continue to show the same progression. Let's follow this linear progression for now. The subsequent components are related to the results. Near the end of today's episode, we will talk about the loop structure. In sentence 3, which shows the unknown component, the authors tell us their main question. And with this sentence, the authors finished setting the stage, and they are ready to tell us the experimental results to answer their question. Then, the following three sentences show us the three lines of research results. They are presented in a linear and sequential fashion. Sentence 4 shows result number 1 of the results component. Using model human cells in culture, called the HEK293 cells, the authors showed that the unmodified RNA triggered immune responses, but the modified version of RNA did not. Sentence 5 shows result number 2 of the results component. The authors extended the research from the model cells to the human dendritic cells, the cells responsible for innate immunity in the body. The authors found similar results to those found in the model cells. Sentence 6 shows result number 3 of the results component. Here, the authors introduced an integrated and evolutionary viewpoint. Using both the model cells and the dendritic cells, they showed that immune responses were triggered by the total RNA derived from bacteria or bacteria-like mitochondrial RNA, both of which are rich with unmodified RNA. In contrast, immune responses were not triggered by the total RNA derived from mammalian cells, which are rich with modified RNA. Then, based on these sentences 4 through 6, the next sentence summarizes the results. Sentence 7 shows the conclusions component. The authors said that modified RNA did not trigger immune responses. So the authors started with sentence 3, that is the unknown component. They went through sentences 4, 5, 6, that is the results component, and the authors ended with sentence 7, that is the conclusions component. This was a clear linear progression from sentences 3 through 7. I have 2 comments about the results component. Results component, comment 1. Sentence 4 with the result number 1 mentions 5 modified nucleosides that the authors tested. It is very interesting to note that the last of the 5 was pseudouridine. In the episode 46, I said that this modification was emphasized in the Nobel Prize presentation video on YouTube. But at the time, I forgot to mention one thing. It was that this modification, pseudouridine, was further modified later to N1-methyl pseudouridine, and this was introduced in the messenger RNA vaccine against COVID-19. Results component, comment 2. I found another interesting thing about the results component of this abstract. I said that the 3 lines of evidence, results number 1, 2, and 3, were presented in a linear and sequential manner in the abstract. But this order of presentation in the abstract was different from how the data were presented in the results section of the paper. In the results section, the data corresponding to the abstract were presented in the order of the result number 3, then result number 1 and 2. Result number 3 was about the evolutionary origin of RNA and how the evolutionary origin affected the degree of triggering immune responses. The corresponding data of result number 3 were shown first in the 6-figure paper, not near its end. They were shown in figure 1 that used the dendritic cells and in figure 2C that used the model cells. There, result number 3 of the abstract was described as a starting motivation to examine the effects of modified RNA. It was described this way in the results section of the paper and in the YouTube presentation video by the Nobel Committee. So in the abstract, the order was the results number 1, 2, 3, but in the results section of the paper, the order was the result number 3, 1, 2. It may have happened in the following way for the 8-sentence abstract. When the authors had thought about where to mention result number 3 in the abstract, one clear and normal option was to describe in the same order as the results appeared in the figures, that is, in the order of result number 3, 1, 2. But they could have thought that result number 3 about the evolutionary origin of RNA would form a better link with the last sentence, sentence 8, which is the implications, by putting the results in the order of the result number 1, 2, 3, instead of a normal result number 3, 1, 2. This way, the overall story will read more linear and logical. And this order aligns with the latter half of the title of the paper. The title reads, quote, Suppression of RNA recognition by toll-like receptors, the impact of nucleoside modification and the evolutionary origin of RNA, close quote. In my experience, I have not seen a strict rule that says that the results component in the abstract needs to be described in the same order of the corresponding figures and tables in the results section of the paper. So I think our abstract is logical, it makes sense, and it is beautifully organized. Now, comment about the loop structure. Let's talk about one of the 2 loops that I mentioned at the start of today's episode. Sentence 7 corresponds to the conclusions component. The authors say that modified RNA did not trigger immune responses. The conclusions component summarizes all the findings and gives a clear answer to the unknown component stated earlier in sentence 3. Do modified RNAs avoid triggering immune responses? And the answer is clear yes. This is the loop. This loop is opened with the unknown component, that is the major question of the work, and the loop is closed with the conclusions component. In between this loop opening and loop closure, usually there's a linear sequential statements of the results overview component, the methods component, and the results component. Our abstract did not have the results overview component and the methods component, but it is okay. So sandwiched between the loop opening and the loop closure, there were result number 1, 2, 3 of the results component. After reading the conclusions component, I would go back to the unknown component and read it again. Then I would understand that the question is answered clearly, and the question-answer pair will make sense, and I would feel satisfied as a reader. This is the first of the 2 loop structures within a well-written abstract. Then you might ask, Dr. Synaptologica, why do you emphasize this loop structure? A question should be answered by an answer, so there's no need to emphasize it. Well, in reality, in my experience, I have seen many abstracts that were not written in an ideal manner. The questions and their answers do not match. During a linear progression, a line of logic somehow deviates from the main line in such abstracts, and the loop is not closed cleanly. It is not a good sign. In such cases, I often find that the remaining sections of the paper are not well written either. The reason why I want to emphasize the first loop structure is that when it is opened and closed well, it shows a good thought process of the authors. It is a good sign. And we can see one of the best examples of loop structure in our abstract of the Milestone Article 1 of the Nobel Laureates. Please note that it is different from circular logic, which is a bad feature. In a typical circular logic, the same claim is repeated without external evidence. Our loop structure in an abstract is a very good feature. Summary. Today, we talked about sentences 3 through 7 in the abstract of our Milestone Article 1. We saw 2 logical structures, both starting with sentence 3, the unknown component, and ending with sentence 7, the conclusions component. In one logical structure, the story showed a linear and sequential progression of the structural components. The story proceeded down a straight line. In another logical structure, the story showed a loop. A loop was opened by raising a question as the unknown component, and the loop was closed by answering the question with the conclusions component. We can happily read the unknown and the conclusions components back and forth multiple times. And we feel satisfied because the story is straightforward and clear. I am impressed by the 2 logical structures, especially the way the loop closes cleanly. In other words, I'm impressed by how clearly the major question, the unknown component, is answered by the conclusions component in this abstract. Your action. When you read an abstract of any paper next time, please pay attention to whether or not the loop in the abstract is closed cleanly. Do you like the abstract? Do you like how the rest of the paper is written? Please tell me your experience and how you felt when you read the paper. My email address is ideas@synaptologica.com. Thank you for joining me in today's episode of Foundational Skills in Life Sciences. I'm Dr. Synaptologica. I'll see you soon. Bye for now.